Okay, in lesson 10 here, and we are going to be exploring functions built out of linear pieces. We call these piecewise functions. Make sure you write that term down. Okay, this is a what do you notice and what do you wonder question. Write down at least a couple things that you notice and wonder, and then start the video again. The main thing here that you should notice is that there's both dots and lines on this graph, and you may be wondering why. The main thing here is that the lines are modeling what's happening in the graph in different sections, or in this case, different pieces. That's why it's called a piecewise graph. So that's what we're going to be seeing is how do we model different parts of a graph by using different lines. These two graphs are not in your book, but we're going to just use them for a little comparison here. This first one is the one that you just saw in the notice and wonder, and we are modeling this with two different lines, one going up and one going down. The second graph is showing how we can better model this using more lines. So we have 1, 2, 3, and then 4 lines modeling this, and it does match the data better and gives us a better picture of what's going on. Okay, first thing I want you to do on this problem is just number 1. You're going to be approximating the percentage recycled each year with a piecewise linear function by drawing between 3 and 5 line segments to approximate the graph. So go ahead, do that, and start again when you're ready. Okay, you can see how my piecewise function ended up. I ended up with 1, 2, 3, 4, 5 pieces. It can be different. The goal is just to model the data as best we can. Now, number 2 says to find the slope for each piece. We're going to do this for just one piece, and we're going to find the slope of this piece right here. So create a line there if you don't have one already. I've put the coordinates of the end 2 points, that point and that point, on the graph already, so get those written down. And to create our, or to find our slope, we will create a slope triangle. So there we go. And our x values, or our run, went from 2011 to 2013. So that would be a run of 2. And our rise went from 25.5 to 26.5, so that's a rise of 1. Rise over run tells us that the slope is going to be 1 over 2, or 1/2. Now, what does this tell you? That's more important here. And what it's telling us is that during those years, the amount of recycling, or amount of garbage that was recycled, decreased by 0.5% each year. We know it decreased because it is going downward as we go left to right. Okay, on activity 3, you're looking at a graph of a dog bath. And I want you first to do questions 1 through 4 on your own and then start again. Okay, looking at questions 1 through 4, number 1 asks you to add labels. So here it is, time and the water in the tub in gallons. When did she turn off the water faucet? Well, these first 6 minutes is where the tub is filling. So she turned it off there at 6 minutes. How much water was in the tub when she bathed her dog? This amount of time right here is where she was bathing her dog, and there was 24 gallons in the tub. And how long did it take for the tub to drain completely? Here's where it was draining. So it drained from 18 minutes to 30 minutes. So that would be 12 minutes to drain the tub completely. Numbers 5 and 6 are looking at rates. We're going to do number 5 together, and then you're going to try number 6 on your own. At what rate did the faucet fill the tub? So filling the tub was right here. I'm going to make a slope triangle and look for my rise and my run. So my run went from 0 to 6, so that's 6. My rise went from 0 to 24, so that's 24. Rise over run, 24 over 6, or that simplifies to 4. Now the important thing here is the label, and what does that mean? Well, the label is going to be gallons per minute, and so what we're saying here is that we are filling the tub at 4 gallons per minute. All right, right now go ahead and try number 6 and start again when you're ready. Okay, on number 6, the rate she was draining the tub, it should be the slope 24 over 12 or something similar, which simplifies to 2 gallons per minute. Now this really should be negative. Add that on there if you don't have a negative sign. And it's negative because it's draining the water. Okay, the last one, distance and speed. This graph kind of has the same shape as the dog bath, but it's very different. It's showing the speed of a car as a function of time. You are going to simply describe what a person watching the car would see. Go ahead and try it and start it again when you're ready. Okay, if you're watching this car, you're going to see the car start from not moving, and it will speed up quickly, and then it's going to keep driving, but it's keeping the same speed, and then it will slow down slowly until it stops. One thing to note here is that it sped up more quickly than it slowed down. Okay, just reviewing with our learning target for today, the main thing is that we were creating graphs of non-linear functions with pieces of linear functions. And again, those were called piecewise graphs.